of our ions. The first one, the cation. If the change is always the same, or charge, excuse me, is always the same, that's your A group numbers. 1A, 2A, and 3A form your cations. You just have to write the name of the metal. Makes it really easy, right? 1A, 2A, 3A, you just write the name of the metal, it's done. What group of metals did we not talk about yesterday? Transition metals. Because transition metals follow slightly different rules. The problem with the transition metals is they don't have a single charge all of the time. Sodium will always be +1 because it always has one valence electron and wants to get rid of that one valence, so it has a +1 charge. Calcium, always a +2 charge. Magnesium, always a +2 charge because they're in group 2A. The transition metals are not in an A group, and the reason we don't number them with A groups is because they can change. Sometimes they'll have one valence electron, sometimes they'll have two valence electrons, sometimes three, sometimes four. It depends on their arrangement. They can move around some of those inner electrons and put them in a different energy level. So that's why they can change the valence electrons. So when we look at our transition metals have some special rules that go along with them. They can have more than one type of charge. Iron, for example, could be an iron +2, +3, or +4. So when we're naming our iron ions, we have to indicate the charge with a Roman numeral. So we have to say iron with a little 2 in Roman numerals, or iron with a 3, iron with a 4. That tells you that it has a +2, +3, or +4 charge. So again, those transition metals, you have to distinguish what charge they have. Now, in order to figure that out, maybe you'll be told what the charge is. Maybe you look at what it's bonding with to figure out the charge. There's several different ways that you can find that charge out because each of those atoms will have different types of charge. But if you see an iron with a 2 after it, you know it's a +2. If you see iron with the Roman numeral 3 after it, you know that it's going to be a +3 Roman numeral, or a +3 charge. So that gives us the ability now to start using those transition metals. Just understand that when you're using that information, you have to either be given the charge or you have to distinguish the charge. You've got to have some way to state that charge, because if someone else reads your paper and they're looking at your combination of elements, they need to know the charge that you intended to make sure that it balances out. So the regular cations are great. You know, it's just a standard name. With those transition metals, again, you have to clarify what charge they have in the name, because looking at the periodic table won't tell you that information. You have to give it to them elsewhere. What's our other type of ion? Anions, huh? Good job. Anions, we have to start with the regular name, but we have to give it the IDE ending. So make sure that you remember the IDE ending. Chlorine becomes chloride, sulfur is sulfide, phosphorus, phosphide. And again, I don't expect you to know those all right now, but you will get more and more familiar as you're working with these. So little by little, those naming parts will come together. So that stuff gives you a little bit of review from yesterday. We add in the transition metals as something to be able to use now. Today we're going to take those cations and anions and start combining them and take a look at how we know how to get different formulas and specific formulas, because atoms are going to combine in set ratios. If you put chlorine and sodium together, they have to have a set ratio, otherwise you're not going to combine them properly, and they won't form your molecules that you need. So our today is focusing just on ionic bonding. And the first thing is any chemical bond. This is not true for just ionic, it's any chemical bond. You're looking at having some type of attractive force that holds the atoms or ions together. any chemical bond is going to have some type of attractive force. It forms because those atoms are finding a way to achieve those filled energy levels. Whether they're sharing electrons, whether they're giving electrons and taking electrons, they're just figuring out a way to get them to be filled. There are three types of bonds. Again, they're ionic, covalent, and metallic. And because of those three types of bonds, we can combine all different types of elements: metals, nonmetals, metalloids. And we're going to learn about the three different types of bonds. Today, again, we're focusing on ionic. Later on, we'll take a look at the covalent bonds. And then we'll also get into the metallic bonds a little bit. The type of bond is going to depend on how your electrons are going to be combined together. Sometimes different atoms will give electrons away. Sometimes they will both use them, they'll share them. And so that type of combination of the electrons is going to cause it to be defined as a covalent or an ionic bond. So as we're going through and learning the different parts, we want to make sure that you take some time and really figure out, okay, this is an ionic bond. I really need to remember how an ionic bond is formed. What is it a combination of? When we get to the covalent bond, really focus on what is a covalent bond, what's combining, what's the difference between those two. Because it's those differences that really help kind of solidify what's going on with your different elements and how they come together. So an ionic bond specifically is when one atom is going to give those electrons to another atom. Again, when one atom is giving electrons to another atom. So that's going to happen between a positive ion and a negative ion, which should be our metals and nonmetals, our cations and anions, one of each. And then those bonds are held together by attractive forces, the opposite charge. So you think of one has a positive charge, one has a negative charge. When you put a positive and negative together, they attract. So those opposites are attracting. I've been yawning like crazy today. Anyone else? That was why. It's ridiculous. I'm just yawning all day long. It's been awful. Okay, so can you underline one atom gives electrons to another? Ionic bond is where an atom is giving electrons from one to another. And it has to happen between a metal and a non-metal. Metal and a non-metal. So if we look a little bit closer at the ionic bond, an example would be sodium and chlorine. Sodium has one valence electron. If you look at its four model, it's got 2 and then 8 and then 1 in the third shell. Chlorine has 2, 8 and then 7 in its third outer ring. Sodium wants to lose an electron. chlorine's going to gain an electron. So when the two of them come together, that electron's going to go over to chlorine, fill it up. Sodium will drop down to one lower energy level. Chlorine fills up its third energy level. And they both end up being ions. You've got a positive 1 charge for sodium, a negative 1 charge for chlorine. The positive and the negative are attracting each other, so that's what keeps them bonded together. And then they both end up being what we would consider to be happy or stable atoms. Okay? They're a good match. Now if you look at the name, we've got sodium, it stays sodium. Chlorine becomes chloride. So when you put them together, you end up with sodium chloride. You just have the name of the metal and then the name of the non-metal with the IUPAC.
Why can't it be chloride sodium?
Oh, that doesn't follow the rule. So if I look at these, use your periodic table, figure out which one of these 6 would follow ionic or would be ionic bonds. Obviously, you know number 1. Good job.
Wholly an ionic bond.
Don't say it out loud. Don't say it out loud. Just know in your head which ones are ionic compounds. Obviously, number 1 is. Everyone looked at them all?
No.
Okay. Everyone good? First one, we already said I gave that one as an example, so obviously it is. How about 2?
Yes.
CO2.
Yeah.
What is carbon?
And then, oh shoot.
Two oxygens.
Carbon, non-metal or metal? Non-metal. What's the rule? Metal and non-metal. So carbon's a non-metal. What's oxygen? Non-metal. Is that an ionic bond? No. How about carbon and oxygen?
No.
No. How about K and F? Potassium and fluorine? Yes, because K is potassium is a metal. Fluorine is a non-metal. How about aluminum and oxygen?
Yeah.
Where's aluminum?
Metal.
It is a metal. It's in group 3, it's a metal. Oxygen, non-metal, so that's good. How about sulfur and oxygen?
No.
No, sulfur is in group 6. It's a non-metal, right? Oxygen, non-metal. So only 1, 4, and 5 are ionic bonds.
So we don't have to add the electrons, make them so it's like the
You will later on. These ones would fill up perfectly. These are following different rules because they are not ionic bonds. And we'll show you how they work later on. You're trying to jump ahead, which is good.
slow your horses down.
I'm gonna rein you in a little bit. We'll do that. Okay, so 1, 4, and 5. You're looking metal, non-metal, cation, anion combining together. Positives and negatives evening each other out, filling those energy levels. If you look at it from a Lewis dot structure standpoint, we look at sodium has 1 valence electron, chlorine has 7 valence electrons. Sodium's going to give that 1 valence electron to chlorine. Sodium ends up with a positive charge, chlorine ends up with a negative charge. Chlorine's valence electrons are full. Sodium's outer shell, where it was empty. So now it would drop down to its next energy level and have the full energy level at that. Does that make sense? Ties in what we did last year a little bit. So if we look at it again, if we already know about calcium and bromine, if you find calcium on your periodic table, it has 2 valence electrons. If we look at bromine, bromine is way over in group 7. It has 7 valence electrons. So if we combined a calcium with a bromine atom, one of those valence electrons can go over and fill up bromine. But then calcium still has one valence electron. It's not happy. So it would have to combine with another bromine atom and give its second valence electron away to that other bromine. So that's where it starts to look at, how many atoms of each do we need to fill up those energy levels. So like Sophie was saying, when we're looking at getting those energy levels filled, that's how we're looking at the number of atoms. This is for ionic bonds, where the electrons are being given from one to another. So if we combine these two then, calcium would have a +2 charge. Each of the bromine will be a -1 charge. The bromines are full in their outer energy level. Calcium's outer energy level, the outer one where it started with, is empty. The next one in would be its full energy level. So its formula would just be Ca, and then Er with a subscript 2. That subscript just means there's 2 each of those little bromine atoms. So if we start looking at naming things, we've got sodium and fluorine. If we combine sodium and fluorine, we could have 2 possible names. It could be fluoride sodium, or it could be sodium fluoride. Which one sounds more normal?
Fluoride sodium.
Sodium fluoride, because that's what you've heard as sodium chloride. We've said that one a lot. That IDE ending with that second word, that's the one that we would go with. And the reason is, the rule, think about when you're reading a page. You read from what side to what side? Left to right. Where are the metals located? On the left. So the metals come first. What goes on the right? The nonmetals, the IDE ending. So when you're naming these and putting a name to it, the cation will come first, and then the anion will come second with the IDE ending. So sodium and chlorine becomes sodium chloride. Magnesium and sulfur would become magnesium sulfide. You can pick any metal and any nonmetal. The nonmetal just gets the IDE ending at the end. The metal comes first. Sophie,
If you have more than
what's your question?
if you have more than 2 elements,
That will get to polyatomic stuff. We'll give you a sheet, because then those multi-atom stuff will have a new name, just as itself. So it'll have a one-word name. Now, in your name here, do you see any type of subscript or numbering or anything? No. For ionic bonds, you don't need to show how many there are. You have to do the balancing of the charges. You've got to take a look at how many valence electrons need to fill in. When you write the formula, you'll have subscripts. When you do the naming, it just does the name itself. There's no numbers in there. Sodium chloride, magnesium sulfide, magnesium oxide, magnesium chloride. It's just the words. Okay. Sound like something you can do? We're going to look through, we're going to go through a practice one together. Keep your periodic table out, keep your notes out to help you through. We'll be done with adding to the notes. I'm going to do one on the board to help you out.
I can have.
No, you can't take a nap right now. This afternoon you could.
When we get home?
I'm going to say in Fifth Avenue, maybe around 2:30. 2:30 sounds like a great nap time.
I'm pretty sure 11:25 for the room.
We're outside for baseball.
11:25 is on break. We're going to
I've been
Hope you learn.
Alright, so we've got a bunch of examples here for you to go through. Can you get them please? And we're looking at those valence electrons. So your first one, we've got potassium. Alright, we got potassium and what else? Chlorine. Chlorine, thank you. So how many valence electrons does potassium have? One. So draw your one valence electron for potassium. How many valence electrons does chlorine have? 7. So draw your 7 valence electrons for chlorine. Your choice. You can spread them out if you want to. Okay. What is potassium going to want to do?
Take 7 electrons.
Get rid of it. What's chlorine going to want to do? Take it. So what I want you to do is draw an arrow from your potassium's valence electron to where it's going to go. Don't draw it on the chlorine. Just draw the arrow for it. Then we've got this big arrow over here. What does this big arrow mean?
Transition bond. What is that?
It's kind of like a math equation. You've got this before. These two come together. When they come together, equals in math. In chemistry, it means yields.
Oh, so like what it makes.
Produce.
Right.
So add a yield above that arrow. Potassium plus chlorine yields, produces, okay, same kind of thing, yields or produces. And then we've got KCl here. Well, we drew an arrow, we showed where that goes. So now over on the chlorine, we've got our 8 valence electrons now.
One potassium have 8 valence electrons too.
The shell that we were looking at for potassium is now empty, that original shell, because I gave it to chlorine. What charge is potassium left with? Plus 1 charge. So add a little plus 1 in the upper right-hand corner. What charge is chlorine left with? Negative 1. Okay. Am I making sense so far? The last little part that we need you to do is the naming and writing the formula for it.
Formula. Secret formula?
So if I wanted to write the name for these, what would I name these? Potassium chloride. So you've got a parentheses and go ahead and write potassium chloride. And then there's a comma on the end of the parentheses. The second part is what you want to write, or where you want to write the formula. What does our formula look like? Just KCl, no space, capital K, capital C, and the lowercase l. So for each of them, you're going to show the valence electrons. You're going to show where those valence electrons are going, what comes out of it, and then name them and write the formula for them. What happens if I had something that required 2 chlorine atoms? How would I show that on my formula? Charlie?
You would put a little 2 under the L.
Little 2, yeah. So if I had KCl, if I had 2 chlorines, it would be KCl2. What if it was 2 Ks?
Be K2Cl.
K2Cl. Okay. So make sure you keep track of that when you're writing the formula. Do I change anything with the name if I add different ones? No, it's just the formula. Obviously this one doesn't. This one just has 1 potassium and 1 chlorine. But later on you're going to get more and more. Okay. Good? Use your periodic table because you need those valence electrons. For tomorrow, your yellow sheet is due and then the remainder of your green packet.